Welcome, everyone, for our virtual tour of outer space. My name is Josh, and I am honored, nay privileged, to be beaming from my house to yours for our virtual tour of outer space. I work at Morrison Planetarium, and I got to say, we are very excited to be sending out to you something kind of like we do for our normal planetarium shows. In fact, using the same planetarium software that we use in our dome, this is something called OpenSpace. OpenSpace often is something that you'd have to download. A lot of planetarium software, I should say, are things that it's tough to download, or they have very expensive licensing fees. But this is one you actually can download, install on your home computer, and basically fly the exact same tour as I'm about to give in your own home, maybe for your family. Gather them all around, then you get to be the planetarium presenter. If you want to check it out, it's on openspaceproject.org, and it is a very cool thing to check out. Okay, now, while we are getting closer and closer to what's going to be happening today, I wanted to show you this planet first and foremost. This is the planet Venus. Now, looking down on Venus, it's been in the news quite a bit so far this week because there was an announcement, I believe Monday, but time has been absolutely flying, about the atmosphere of Venus, and specifically something that was discovered in the atmosphere of Venus. What was discovered? Phosphine. Now, what is phosphine? You should ask somebody with a better chemistry background than me, but basically it's something that our noses would detect at some concentration as something that kind of smells like garlic or dead fish. Not at all a pleasant smell, to be sure, but on Earth, phosphine is generally a byproduct of life, and that's really cool. Now, it's not always a byproduct of life. There are ways to create phosphine that are not related to biological processes. So is there life in the clouds of Venus? The answer is pretty much the exact same as it was before. Maybe. It's a possibility. However, there is some good evidence to say that this could be made by something living, and basically it means there's a great opportunity for a follow-up mission. There's only so much you can learn from Earth looking at Venus. Sometimes you have to dive in to really get some discoveries. Thankfully, Venus isn't as hard to send probes to as some of our outer planets, so maybe a mission could be upcoming. Who knows? It'll take a little while to get going, but this is a great spur to get people excited about sending a mission to Venus. And with that, we are looking at the outer clouds of Venus, not at the surface of Venus. We can look at the surface of Venus by pressing one little button, taking away that surface or those clouds, and revealing a place that is really inhospitable. If you thought dead fish and garlic-smelling clouds, or I should say onion-smelling clouds, sounded bad, it's got nothing on the surface of Venus. We actually find water vapor in the clouds of Venus. That's a pretty hospitable environment, all things considered. Once you get to the surface, the thing we're looking at now, you're not going to find a single drop of water. Water would be gaseous at these temperatures. There's almost no chance for it to be a liquid or a solid like ice. What we would be seeing is a rocky surface and maybe some volcanic activity. Some people argue that those very volcanoes could be the source of the phosphine we detected and that you don't need a biological process at all. The number one thing we can confidently say about Venus is that it bears further study. To understand what's making that phosphine, to understand the geological processes that are going on there, to understand how the chemistry interacts at different layers of Venus, and even just how phosphine can occur, we need more study. We need more research. We need more science to be done. There is by no means a closed book on any planet in our solar system, especially one as mysterious as Venus. Now, backing out now, if there's another spot in our solar system that you think would be cool to visit, let us know. Drop it in the comments, and I would be delighted to take us someplace else. Also, at the very top of our program, I forgot to mention that we have a brand new survey available that if you want to fill it out, please do so. Bing can drop our link in the comments. And when you fill out this survey, our friends at NASA and the American Museum of Natural History would love to know what you are thinking. So if you want to check out SurveyMonkey link, Bing just put it in the comments right there. Thank you, Bing. You can give them feedback on this, and I believe the first 30 participants get a NASA sticker mailed to them, so definitely worth it. Now, we are heading away from Venus, heading out to our next-door neighbor planet on the other side, Mars. Why Mars? Well, we detected phosphine in Venus. That was a really big deal. We detected methane floating around on Mars, I think about 2 years ago, and that was a really exciting discovery as well. And for sort of similar reasons. We know that there is biogenic methane produced by life here on Earth. In fact, it's something that we often associate with cows and their burps. But that methane is a greenhouse gas. Not great for our planet given our current considerations, but there are worse greenhouse effects overall. But when we see it on Mars, this is a really exciting thing because it could be evidence of some bacterial colony or something underneath the surface burping. Now, that would be pretty cool, to be sure. It would also be cool if there's a rock process on Mars producing methane. So if we learn more about methane and its production on Mars, we might gain further insight into Mars on the whole, but also the possibility of life on its surface. Mars is a really amazing spot. If you want to find out a little bit more about Mars and its potential for life, I would encourage you to tune in this Friday when we are having a cosmic conversation all about the possibilities of life elsewhere in our solar system with our SETI scientist friend, Catherine Bywater. Dr. Bywater is going to be telling us about the possibilities for life. And if you'd like to ask someone who really knows what they're talking about the discoveries on Venus, she would be one of the people to ask. She's going to be talking about some of the really cool features we see. A special sneak preview, if we dive in here, on the sides of one of the three mountains, the three volcanoes that makes up the Tharsis Plain, you can see some RSL. Now, what are RSLs? They might be a life possible spot on the surface of Mars. As soon as our data tiles in, right along the side of this volcano, if our high-resolution photos come down, you can see what are called reoccurring slope lineae. Lineae means line. Reoccurring shows up over and over again. Slope, on the slope of the mountain, we get dark features that show up over and over again, which might be evidence of briny water still around on the surface of Mars. Now, if that doesn't sound like a life possible environment, I don't know what does. Outside of Earth, that could be one of the most hospitable places in our solar system. Speaking of hospitable, though, we were just talking about a super cool ice moon, and one that I always like to visit. Twist my arm. I'm going to name this my favorite moon of today's broadcast. We are heading out to Europa. Now, Europa is beautiful. If you want to see Europa with binoculars or a telescope, point them at Jupiter. Jupiter is very bright in our night skies, and the southern sky, when the sun goes down, that very, very bright thing that you think, that's a plane. No, that's Jupiter. There aren't that many planes flying right now, so it's way more likely to be Jupiter than any other time. But when you look at Jupiter's moons, there should be 4 little dots swimming around it, depending on the size of your telescope or binoculars, and one of those is Europa. Europa is very reflective, even though it's small, because this tiny moon is paved in a wonderful icy crust. That icy crust has cracks and features all over it. They crisscross each other. We talked about their breaks last week, how one feature can overlie others. It's just a really cool surface to observe. If any of you have downloaded OpenSpace, this is one of the coolest things to check out. Just fly to Europa, zoom along the surface, and see what kind of weirdness you can discover. It is an amazing place, and there's lots of high-res, interesting images for you to see. Let's check out on the other side over here, and you get a completely different kind of surface. This looks so much smoother and much less scarred. The lines are longer and straighter. I can't tell you why. All I can see is that I definitely notice a difference, and then it's a completely different story right here with this dark patch. Enrique says it looks like car tracks. I might agree. If we ever get vehicles to Europa, watching races across an icy surface like that would be pretty good TV. But I also think just about the scariest possible race to be on. Low traction, sliding around, very low gravity, so the jumps would be pretty prodigious. Sounds like an exciting thing to watch. I would not be racing in it. Okay, backing off from Europa. We talked about that as a potentially hospitable place. I forgot to mention why, so not backing off of Europa. If you sliced Europa in half, about a third of the way down would probably be water. Now, that's really cool. From the surface down, you'd get a thick layer of water wrapped around a rocky structure, with probably some radioactive stuff and some metal way down in the middle. But that water is a huge volume of water, maybe one of the biggest repositories of water in our solar system. And up until this year, I would have said was the biggest repository of liquid water in our solar system. But now we have another contender, another potential watery place that could be a wonderful bonanza for human beings should they ever leave Earth behind and need water out there in space. Ceres is probably the place to go. Now, Ceres exists in the asteroid belt. That's right between Mars and Jupiter. When you look around on the surface, you're going to think, oh boy, you missed the boat, Josh. There is not a single drop of water to be seen, and that doesn't look like ice. That looks like rock. I would agree. But recent estimates, in fact, a paper published not too long ago, suggest that there is a huge volume of water inside Ceres, and this could be the biggest water reservoir in our solar system. The early hint was these white spots right here inside this giant crater. Now, these white spots seem to be Epsom salts, water-soluble salts that have been deposited on the surface, maybe where water flowed up and left them behind as it evaporated. That possibility of water inside Ceres is very exciting. Ceres by itself is a weird-looking world. It's got interesting craters. It's not really round. If you look at it, some of its mountains and peaks are just too tall. They extend up way beyond where they would if this was an Earth-sized object. They're able to do that because this is a relatively low-density object. Water is not dense compared to metals. And another very interesting fact is it's small, teeny tiny, much smaller than Pluto. And small objects don't crush themselves quite as round. So when you see something that's almost round but not quite, like Ceres, it's probably not that big. And for really small objects, they actually don't get round at all. Let's see if we can find something a little bit closer to home. Right at the orbit of Mars, let's go check out Phobos. Now, I'm going to say Phobos is my second favorite moon of the broadcast, but Phobos is a weird moon. First and foremost, it has more in common with the asteroids, I would say, than with Europa or our moon. But it doesn't have much in common with Ceres, and you're going to see why right here. Ceres was almost round, so close to round it was practically there. Phobos is nowhere near round. So just by looking at it, you can determine Phobos is a lot smaller. Now, this is what we would call maybe a space potato. Great term from astronomers, an irregularly shaped object, but this is actually a moon because it's going around a planet. And then you start figuring out that, well, the terms like moon and planet are maybe not as firm as we want them to be. Now, following up on Enrique's comment, you can see some similar looking kind of racetrack, car tracks over here going around the surface, and a lot of lines on this side. That's really unusual, maybe evidence of cracks from a collision. But Phobos is small. That's really the point I want to hammer home. This small object is puffy and porous. It seems like it might have been torn apart and reformed multiple times. It's not a very solid, rocky structure. Now, zooming back from it, keep that idea in mind. When you see something that's just really small, it doesn't get round. When we look at the two biggest things in our solar system, they are both pretty much perfectly round, except for one thing. That is going to be Jupiter, our very biggest planet. And Jupiter is spinning so fast. How fast? Ooh, that was cool. Check it out. Flew right past Io, another volcano moon. Right down here, when we look at Jupiter, we can see this beautiful, perfectly round thing. But is it perfectly round? Well, there's no mountains, there's no bumps sticking off, no peaks like we saw in Ceres. But interestingly enough, the middle part is wider than the top to bottom distance. Imagine chucking pizza dough. As it spins, it extends out in the direction that it's spinning. When you spin it over and over again, it flattens and gets wider and wider, but shorter and shorter, more compact from top to bottom. That pretty much exact same phenomenon is happening to Jupiter. As it spins, the middle bulges out, and the top and bottom get a little closer together comparatively. But the change is small. If you were to measure Jupiter in Earths, you could fit about 10 Earths from the top to the bottom. it would take about 11 Earths to go from side to side, just in terms of one Earth diameter compared to one Jupiter diameter. Now, thinking about that, let's look at the biggest thing in our solar system, which is the sun. The sun is spinning. The sun is spinning pretty quickly. The sun is not a perfect sphere. It's spinning so fast. Ooh, I got to turn that sun glare down, or else we won't even be able to see the sun. There we go. This looks a little weird without the glare, but forgive me. It doesn't have quite as much bulging as Jupiter, I believe, but I would want to double check. But it does have some. Again, because it's not a solid object. The sun's made of plasma. It's kind of squishy, all things considered. There are stars out there like Regulus that are spinning so fast, it's actually sort of lentil or pumpkin shaped. Our sun isn't doing that. Our sun takes, I think it's about 23 days. I'm thinking about this. Our sun's rotation is either 13, 28, or 23. And the other one is an annual magnetic cycle, but I can't remember which number. But it's a really interesting object, and it does spin. It has differential rotation, so the middle part spins faster than the top parts, which is actually one of the things associated with solar storms and sunspots, which is really cool, but I'm getting very distracted. I wanted to show you Regulus, and for that, we have to find our good buddy Leo. Leo the lion. Let's see, we got Taurus. We're going to follow our zodiac. Yep, we're in the southern sky. I'll keep looking for it. But in the meantime, if there are any other objects y'all want to check out, please let me know in the comments, and I will very happily stop hunting for random constellations and fly wherever you want to go. This is kind of fun for me. I hope I'm not making anyone sick at home. Whee! Okay. Zooming back. Let's see. Any comments? 27 days. Thank you, OpenSpace friends. Haumea! Enrique, you're killing me. I wish I could show you Haumea. I don't have that model loaded up. That is a super cool thing to request, though. If y'all want to learn about Haumea, it is an amazing object on the outer part of our solar system. A lot in common with Pluto. Hangs out in the Kuiper Belt areas. Okay. Ooh, we got a cool question coming in about seeing the sun looking a little different. Now, when you look at our sun right now, it looks red-orange, right? Well, that's what would happen if you looked at the sun through the correct kind of solar filter, where it blocks a lot of the light coming from it. Now, if you saw a pink or red sun from here in California recently, the sky was acting kind of like a filter, but smoke's not a very good filter in that it doesn't reliably block the right kinds of light. So number one, it's tempting. I know it's so tempting to just stare at the sun when it's smoky. It's not a great idea, just in case it's not blocking enough light. It can make it pretty dangerous for us to just stare at it. Number two, you get that really cool reddish yellowy color. Ooh, a request for the Pleiades. I will head there in just a minute. But the color we're seeing is also partially because of the smoke itself. And the very last reason it's not great to stand outside and look at the sun for a long period of time is because that means being outside in that smoke for a long period of time. Now, we're going to zoom in to planet Earth, and I'm going to take us over as Earth is tiling in. Earth's not usually see-through. I want you to know that. We're building Earth very quickly. Let's see what we got. Okay, so this is an awesome photo of Earth taken by a combined NOAA and NASA mission. Now, this spacecraft is building a photo of the surface of our planet once every single day. Now, if we look at it from just the right distance, we actually get a photo that was taken yesterday. You can see a couple really interesting things. First of all is the smoke we mentioned. All this grayish cloud, that's smoke coming from the California and West Coast wildfires. That's kind of scary. But you can also see the thing that's kind of saving us in the Bay Area today. This giant jet of air coming from the southwest is pushing cleanish air off the ocean and giving us a well-deserved break. Now, that's kind of nice. There's still a lot of firefighting to be done before we are safe and before these fires are out. But I, for one, I think speak for a lot of Bay Area residents when I say we are very happy to have this single breath. Kelly wants to see Saturn. Okay, let's head out that way. Heading from our inner solar system, where we spent a little bit of time, brief jaunt out to Jupiter. And I guess you could say Ceres is part of the outer solar system. Saturn is much farther out, about 1 billion miles from our sun. And you can actually see, this is really cool, 2 moons right there. 1, 2, hanging out in view. That would be a weird coincidence to see 2 moons on any approach, except that Saturn has more moons than any other planet. So it gets a lot less credit for a cool alignment like that than anybody else. If you're a Saturn fan, I apologize. I'm a little salty. Jupiter's my favorite planet, and it got most moons title stolen from it. You can see the shadow of Saturn falling on those rings. The rings are still slightly visible, which would be a kind of idealized view. They'd probably just disappear without sunlight hitting them. If we go to this direction, though, you can see exactly how thin those rings are. From the right angle, they kind of just disappear, which is another beautiful effect of that shocking feature. Now, you can see the rings projected onto the surface of the planet. You see these weird little gaps and skips where the rings look irregular. That's a real feature. Turns out that the tiny moons migrating inside those rings can gather and push apart the debris that makes up the rings, and that will make those tiny concentrations, the slightly more opaque parts that block light from the sun. Okay, stepping back a bit, we have a request to see Neptune. Oh boy, we are getting to the outer solar system, to the very farthest planet from our sun. Okay. Now, this is a long trip. We were making it on spacecraft. We'd be talking about years. When we look at Neptune, we can see a dark blue surface. Now, when you see photos of like exoplanets, they're often these garish, outlandish colors that we're making, I think, a little bit to make it interesting for folks who are opening up their newspaper and seeing that picture. This is not a bizarro fake color for Neptune. This is the color Neptune actually is. Even from Earth, washed out from being blasted by sunlight, we get to see kind of an interesting darkish blue feature. That's really cool. When you point your telescope at Neptune, you can see that bluish glow. It's a little bit more white than blue, but it is still pretty blue. You can see the dark spot of Neptune, that great depression right there, almost a dent in the surface, surrounded by bright white clouds. That's an interesting feature of Neptune. We do see dark clouds and light clouds. Same thing on Uranus. And again, like Venus, proof that we really don't understand what's going on with a world like this. We would love to say we've got an analytical, deep understanding of the different layers of Neptune's atmosphere and how they interact with each other, but that would be a lie. We've got no idea. We know a little bit about the outside. We've got models that tell us what the interior parts might be like, but we need more lab work. We need more studies before we can really have a confident explanation of what's going on here. Can we fly through the Kuiper Belt? Oh man, I can fly us out to about where the Kuiper Belt is. And if you download OpenSpace, you can fly through the Kuiper Belt. But my computer gets really sad when I turn on all of the Kuiper Belt objects to the point where sometimes it turns off. So, for stability's sake, I elected to not turn on the Kuiper Belt. But if you want to check it out again, download the software and by all means dive in. The Kuiper Belt is a super cool region and you can check it out. Okay, looking around, let's see. We had a request for the Pleiades and I will apologize. I kind of spaced. But if we go looking long enough, we should be able to spot it. That's our southern sky again. It's always a little difficult without a horizon, trying to figure out exactly where everything is. But I see the right neighborhood. We have Orion right here. You can see that distinctive belt, the star Betelgeuse, and then Rigel. And then going up this way, we get Taurus the Bull, Aldebaran, its brightest star. And then right there is the Pleiades. Now, the Pleiades is super cool. Let me see if there's anything further I can offer you with the Pleiades. Again, I've turned off a lot of stuff to make things run a little smoother for me. But let's find out if there's anything in here we can go visit. No, the stars are only one single entity, so I can't fly us out to any. We need to make another profile so we can show you some cool stuff. We had a cool request, Milky Way. I could be super snarky, Yelim, and say everything we're seeing is part of the Milky Way, but that's a lame answer, and I don't want to be that snarky. But we can actually see a little bit of Milky Way right now. If you look off in this direction, check out this hazy part. That would be Milky Way. You can see little dark clouds in it. If we keep spinning, you can start seeing it get a little thicker, a little thicker. It's going all the way out to here now. You can see Andromeda hanging just above the plane of the Milky Way galaxy. And then as we go farther and farther this direction, ooh, this is getting interesting now. We're getting to the very dark central vein of the Milky Way and then that lighter glow on the outside. As we keep getting closer and closer, we are at Milky Way Grand Central Station, actually called Galactic Center Point. But if you wanted to find the galactic center point for yourself, there's some cool ways to do it. All you need to do is find a constellation called Sagittarius. Now, it's a little tough at the moment, but it should be right around here. I'm going to throw Bing under the bus because he's producing for me. If you want to find out how to get to galactic center point, ask him tomorrow. Sorry, my dog is communicating with us too. Ask him how to find the galactic center point, and he can tune us into the exact center of the Milky Way through the constellation Sagittarius. Now, looking down here, actually, Tammy, to answer your question, there is a black hole way down there at the center. If you were to have none of this gas and dust blocking our view, we'd see a bright golden glow right there of ancient stars. Now, the ancient stars are surrounding the galactic center point. At the galactic center point is a big old black hole, a supermassive black hole, in fact, not just a cool album from Muse. But that supermassive black hole is maybe the seed that started our galaxy, or our galaxy started and then material accumulated there. There's ideas from both sides. Now, zooming back, we're moving away from our sun, and you'll start to see the stars that make up our galaxy. And as I keep moving farther and farther back, we move outside our galaxy. And again, as a space-saving measure, I think I've turned off a lot of our extragalactic stuff. But you can get a sense of how thick the plane of our galaxy is. And then coming back to that thing we pointed out before, just above the plane of our galaxy, check out Andromeda. Andromeda, right over there, is about the same size as our galaxy. It's another galaxy, and the most distant thing you can see with regular old human eyeballs. It's about 2 million light years away. So we're seeing light that left it 2 million years ago. Now imagine, one day, several billion years from today, this thing is going to look bigger. And that's because it's getting closer. That 2 million light years is shrinking. Over time, it's going to get larger and larger in the sky, and one day it's going to collide with our Milky Way. Think about this. We will always pretty much have our plane of our galaxy extending across our view right here. But then as Andromeda gets closer and closer, eventually it's going to cross the plane of our Milky Way. So we'll have sort of an X of galaxies in the sky. That sounds amazing. That sounds like the coolest thing ever. If you want to check it out, this is not going to be something to miss. Make sure you set your calendars for about 5 billion years in the future. About 3 when we do our first interaction. No, excuse me, it's 1 billion for our first hit and a merger over the next few billion. Aaron wants to know, how did Saturn get its rings? That sounds like it should be a Rudyard Kipling story. Let's head there one last time and check it out. Now, when we first saw Saturn's rings, when we had our first generation of telescopes, we really thought they were a solid thing, kind of like a hula hoop stuck around the planet. That's not the case. We've modeled it and figured out that a ring wouldn't be stable. It would eventually fall in if it was one solid object. So instead, astronomers came up with the idea that we're seeing lots and lots of gas or dust trapped in orbit around Saturn. That's a little closer. Probably not gas, probably dust and rock, and somebody suggested ice. Really cool. Then we sent missions there, and we figured out that it's not much dust and rock. It's mostly ice. Well, it turns out that Saturn has a lot of ice moons. So one possible origin story for those rings is we are seeing a moon that got too close to Saturn and got shredded by gravitational forces. Now, that shredding broke it up smaller and smaller. Those parts bonked into each other and split. Those parts bonked into each other and split. And eventually, they just ground each other fine enough to form this ring around it, and the ring's not terribly stable. We think the ring is slowly falling into the surface of Saturn, or potentially being boosted or disrupted by its moons. Now, don't be too sad. Saturn's got lots of moons. It might digest another one someday and make a new set of rings. But turns out all of our giant planets have rings, our gas giants and our ice giants. Jupiter has a ring, Saturn has a ring, Uranus has a ring, Neptune has a ring. Just turns out Saturn has the best agent, so we all know about Saturn's rings. With that, I think we are getting pretty close to time. I hope I've answered most of your questions. If any of you have further questions, something you would really like to know an answer to, drop it in the chat, even if the stream is over. We will circle back for the next few days and do our very best to answer any questions that pop up. But as we are heading back into our very own corner of our solar system and the universe, planet Earth, I would like to thank all of you for tuning in, watching our broadcast, asking those wonderful questions. I would really appreciate it, so would the folks at AMNH, if you are able to fill out one of those questionnaires and let us know what you think of programs like this. It would be an absolute delight for us. We can make them better, and we can prove to folks how much people enjoy tuning in and watching a broadcast like this. So with our weird see-through Earth again, I would like to thank all of you for joining us. I hope you are staying home and happy and healthy. Download OpenSpace if you're feeling a little claustrophobic and you want to stretch your legs out here in the universe. On behalf of myself, Morrison, Planetarium, OpenSpace, and everyone, thank you for joining us and have a wonderful rest of your day.